Hi, this is the first video in a tutorial series about Inventory X. We're on Unreal Engine 5.7. But the API are the same for previous versions as well. Since the plugin is an inventory system, there are no particular prerequisites. In fact, I'm using the default Unreal character plus a custom animation blueprint for future videos, so I can switch between the unarmed and rifle arm poses based on the equipped items. It's not required to understand the plugin, but it obviously looks better visually. So, we'll take these 10 minutes to create the first definitions that we'll use, that is, the data assets. Inventory X makes extensive use of data assets. We'll use them to define containers, items, and fragments, as well as to define rules and policies. When we talk about anti-cheat in Inventory X, it does not simply mean server authoritative. Server authoritative logic is only one aspect of building a secure system. Imagine a corrupted client that can call any function in your project. Would you feel safe? Exactly for this purpose, rules and policies help Inventory X maintain network security behind the scenes. Now let's create all the folders we'll be using in this episode. So as a first step, let's create the defs folder where we'll store all the definitions required by the plugin. Inside this folder, let's create the containers folder, the rules folder, the cosmetic folder, and finally the items folder. These folders will organize all our data assets, keeping containers, rules, cosmetic data, and regular items separated for easier management. Then, in future videos, we will also create the fragments and the various policies. But these are more complex concepts, so they will come in the next episodes. Create the icons folder if you want to use your own images. I'll be using the example icons that come with the plugin. They were generated with ChatGPT, but they are still great for prototyping. Now we can start creating the data assets. In the containers folder we created earlier, let's create a new data asset of type inventory container definition. We'll name it CD_player main grid. CD stands for container definition. Pay close attention not to confuse containers with inventory. The inventory is the component that manages everything, while a container is a virtual space inside the inventory. You can have as many containers as you want inside a single inventory. For example, in this series we'll have a grid-based container, a slots-based container, like an equipment bar in the style of Ark, Rust, or Minecraft, and another slots-based container for clothing, but in the plugin's sample level. If you want to explore it, there are also other containers inside a single inventory. Since we're setting up the grid-based container, let's set container type tag to containertype.grid. We also set container dimensions to 10 and 8. This way, we'll have a grid with 10 columns and 8 rows. Since we want items to be rotatable inside this grid, we check Allow Rotation. Otherwise, rotating items inside this container wouldn't be allowed. We can leave everything else unchanged. We'll explore it further later, but by hovering the mouse over the various fields, you can already get a sense of what they do. Now let's move on to rules, not to be confused with policies, which we'll see later. There are mainly 3 types of rules. Equip rule. It defines whether and how an item can be equipped in a specific slot of a container. We haven't yet seen slot-based containers or items, so for now, we'll ignore it. Placement rule. It defines whether and how an item can be placed in a grid-based container, like the container we just created. Stack rule. This is the one we're creating now. It defines whether and how an item can be stacked. So let's create our stack rule called SR_non-stackable and open it. This stack rule will be used for all non-stackable items. So let's leave max stack size at 1 and uncheck allow split. Now we need another stack rule. We can duplicate the one we just created. We call the new stack rule SR_stack_05 because we want to assign it to all items that can be stacked in piles of 5. So let's set max stack size to 5 and allow split must be checked, as well as require matching fragments for merge. The placement rule is a data asset that is assigned to the item definition and describes the placement rules of that item inside grid-based containers. It does not decide stacking, that's the stack rule. It does not decide equipment in slots, that's the equip rule and slot profile. The placement rule answers questions like, can this item be rotated? Can this item be placed only in certain types of containers? Must this item avoid certain containers? Now let's create a placement rule and call it PR_default, where PR stands for placement rule. This rule will be the default one for all items that don't have special placement rules. Now let's move on to cosmetic definitions. A cosmetic definition is the data asset that contains the visual, textual, and audio parts of the item. The item definition describes what the item is from a gameplay point of view: tags, size, stack rule, placement rule, equip rule, and fragments. The cosmetic definition instead describes how that item is presented to the player: name, description, icon, color, mesh, and sounds. When the widget receives an item view, it takes the item definition and calls async load item cosmetic. When the loading is finished, it uses the filed icon to set the image, the filed tint color for the color, and the field display name and description for the tooltip. In practice, the item definition is the identity and behavior of the item, while the cosmetic definition is how that item looks and sounds. Keeping them separate lets us change icons, names, descriptions, and visual assets without touching the inventory gameplay rules and without flooding the server with assets it does not care about. If your project is missing a field in here, you can use a static fragment or extend the data asset. So I've created two cosmetic definitions, one for the bandages, COS_bandage, and one for the rifle, COS_rifle. We've given them a name and a description. For the icons, as I mentioned earlier, I'll be using the ones that come with the plugin. All other fields are left unchanged. After I find the icons for these two cosmetics, we'll move on to the item definition. The inventory item definition is the data asset that describes a type of item. It is not the runtime item inside the inventory. It's the template, that is the definition, from which the system creates the actual instances. For example, ID_rifle describes what a rifle is, tags, size, stack rule, placement rule, cosmetic, fragments, equip rule, and so on. When the player receives a rifle, the runtime creates an item record with a unique handle, quantity, position, parent container, and runtime state. The definition is shared by all items of that type. The item record instead is the single instance inside the inventory. All rifles use ID_rifle, but each rifle inside the inventory has its own item handle, its own position, its own quantity, its own runtime fragments, and its own revision. Item tags are the identity tags of the item. They are used to recognize categories and subcategories, for example, weapon, rifle, medical, ammo. They are used by rule queries of containers, equip slots, and other validations. Shape size is the size of the item in the grid, in cells. For example, a bandage can be 1x1, a rifle 2x4. This is the base size, not rotated. If the item is rotated, the system calculates the effective size by swapping width and height. B supports rotation indicates whether this item can rotate. However, that alone is not enough. For rotation to happen, the item, the container, and the placement rule must all allow it. Equip rule. If it is present, the item is considered equipable. The equip rule defines which YOM slots are compatible, any requirements on the owner whether the slot is exclusive, and which tags to apply when the item is equipped. Fragment entries are additional data of the item, called fragments. For example, ammo, durability, condition, custom stats, metadata, or any gameplay state you want to attach to the item. You don't need to have it inside the actor. The inventory manages everything. You simply declare what you want to have. A base item can exist even without fragments. But as soon as we want more advanced state, like durability or ammo, we use fragment entries. Later in the series, we'll explore fragments in more detail. Today's items won't have them for now. Child container definition is for items that contain other containers. For example, a backpack can have an internal container. A pouch can have a small grid. An ammo pouch can have a container dedicated exclusively to ammo. How to create containers we saw at the beginning. ID bandage is a simple item. Medical tag, 1x1 size, stack rule of 5, default placement rule, and bandage cosmetic. ID rifle and instead is a larger item, weapon.rifle tag, 2x4 size, supports rotation, not stackable, uses the same default placement rule and has its own cosmetic. Later we'll add durability fragments, ammo, animation type to change the character's animation, other fragments, and an equip rule to make it equipable. So the item definition is the point where we describe the identity and basic behavior of the item. The runtime then uses this definition to create real instances, validate the rules, and display the item correctly in the UI. Now, the step you see on screen in the project settings is mandatory to do in your real project as well, not just here in the tutorial. The idea is that we need to tell the asset manager that items exist and where it can find them. We need to add a new entry in primary asset types to scan. Both primary asset type and asset base class should be set to inventory item definition. Directories is asking where it should look for items, so you will give it the folder that contains your item definitions. Remember to expand rules and select Always Cook from the drop-down menu. In this video, there was a lot to talk about because we needed to explain how to use all these data assets. In the next video, I'll let things flow a bit more, and we'll see the results of these data assets inside a simple new UI.